All right, this is squares of a sorted array. Um, so given an integer array nums sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. Um, so non-decreasing order means to me that uh, I assume that it's going to mean that there might be duplicates, um, that it's not strictly increasing. Otherwise, I would say increasing order. So okay, so in the example, -4, -1, 0, 3, 10, which they are sorted, um, the output is going to be each number squared, but also sorted. After squaring, the array becomes 16, yeah, and after sorting, it becomes 0, 1, 9, 16. So the end array is intended to be sorted as well. The num's length can be anywhere from 1 to 10 to the fourth. Each num can be anywhere from -10 to the fourth power to 10 to the fourth power. Nums is sorted in non-decreasing. And following up, squaring each element and sorting the new array is very trivial. Could you find an O of n solution using a different approach? Okay, so yeah, I suppose you could just square each element and sort it, in which case I think you would have a um, log n solution, or is it n log n or log n? Probably n log n because you're going through each one once and then you're doing another search. But if you were to do it with an O of n solution, so maybe what you would do is you would probably, I would say what you might be able to do is just go through maybe with two pointers, one pointing to the first one pointer to first element, one pointer to last element, and square them. Um, because one thing I notice is that when you square a number, it doesn't matter if it's negative or not. Um, only the bigger numerical value is going to give you um, a bigger number because you square, you get rid of um, the negative. Yeah, the negative sign. So you square them, you compare them, and higher one gets inserted at the first position of the solution array. Um, Whichever one, increment the first pointer if it was bigger, else decrement the last pointer. Continue on until you reach the end. And in this case, you want to make sure you get the end, get to the end. So, yeah, so, okay. Um, so that's what I'm going to do left, right equals 0, len nums minus 1. Pointer to the first element, pointer to the last element. While left is, I'm going to say left is less than or equal to right because I know that we're going to go all the way to the very last element. While left is less than or equal to right, um, we're going to square them. So squared left equals left 2. Squared right equals right 2. Not equals left 2. If squared left is greater than squared right, we're going to have a res actually. Yeah, res equals empty array. We're going to res insert 0 at the 0 position, squared left. But in all other cases, if it's equals, it doesn't matter. And if it's less than, then we just put in squared right. Like, yeah, if it's equals, like if the squared left and the squared right are the same value, then it doesn't matter which one you insert so long as you insert one. So we're just going to put in else res insert 0 squared right. We're just going to continue to do this until the very end, and we return res. Okay, so let's do a test. So it's already sorted. So we start at the bottom, or start at the first element and the last element. So for nums, if from example 1, the squared left is going to be 16, and the squared right is going to be 100. So that means 100 is greater, so we're going to insert the squared right. So now the solution array is 100, and our left is now 0, and our right is now 4, or 1, 2, 3, 3 at position 3. So now we have 16 compared to 9, in which case 16 is greater, so we're gonna, oh, there's one thing I forgot to do. I forgot to increment and decrement the pointers, and if we don't do that, we're going to run into a Stack Overflow error. Yes, this should be good. Okay, so left plus equals 1. We're going to insert it, so we're going to now have 16, 100, and now left goes to 1, and right is still 3. So we're going to say now left is 1 and right is 3, or 9. 9 is greater, so it's going to be 9, 16, 100. And now we're at left is 2, right, or sorry, left is 1, right is 2. So that means we're comparing 1 to 0, which means obviously 1 is greater, so 1, 9, 16, 100, leaving us at 0. So left is now going to be 2, and right is going to be 2. We're still in the loop because we identified as left less than or equal to right. So now they're both going to be 0. Okay, sorry. So left 2, right 2. It doesn't matter which one, but in the code that we have, if it's anything else, it's going to be the 0. The right one is going to decrement and be inserted. So now we have 0, 1, 9, 16, 100. Left is now at 2, right is now at 1, and that is when our while loop terminates and we return the res. Now, one question, does this work if it's going to be 0? Okay, so num's length has to be 1. So let's say if it is 1, let's say if it was only like 1, or let's say 4, the left is going to be 0, but the right is also going to be 0. Right is also going to be 0. um, we're going to insert 1 into the res, and that should be fine. Yeah, that should be fine. That should give us a 16. Okay, we're going to submit this. Wrong answer. Okay. Squared right 100. So why did this not work? Right equals if squared right squared left equals squared right. Insert squared right minus or equal to 1. Output was 1014,916. Did we? Okay. So the first element that should have been inserted was the right. So while left is less than or equal to right, if squared left is greater than right, squared right is left plus equals insert. Okay, what happened here? So 0 in this case, yeah, going back to it, we would have 0 left is 0 and right is 4. And squared left is going to be equal to 16. Squared right should be 100. If it's greater than that one, which it's not, squared left, if 16 is not greater than 100, so it should have inserted squared right, res insert squared right, oh, that is interesting. I think what I should have done, and I'm not sure how I got so many right ones, it should have been nums right and nums left, and not left and right. Yeah. And now we have solved it. So I should not have been squaring the index. I should have been squaring the element, and that's why, yeah, I had an incorrect answer. So this should be a, what were the conditions of the space complexity should be constant because you're just storing the pointers, or not. No, not constant. It would be linear because you're storing each element in the solution array. But it should be a linear time solution because you're iterating through each element at most once.